And I'll spend as little time in slides as possible because I know people would rather see something in action rather than a bunch of IBM ideas behind it. But just to go through that so that we cover all of our bases. Kind of before I started at IBM, I kind of assumed that all big companies had a very thriving data science department and were using all their best practices in their data strategies and how they house their data, and that's not necessarily true. And that was a big driving factor for Watson Data Platform. So in specifics, what we are looking at is a few different personas of who accesses data and how they use it. So I'll be going through each one of these during this demo. We have the data engineer who may move around data, do some data munging. We have the data scientist who tries to find things in the data, descriptive and predictive analytics, and quite a bit of machine learning. The business analyst who knows an industry very well, but maybe not necessarily how to do too many things with data, but still wants to contribute with their industry knowledge. And then the application developer who puts maybe machine learning into practice or who gets the data from users. And with all of this in mind, the idea is that companies want to ingest their data, store it, do their analytics, and then based on that, deploy applications. So what we're looking at with Watson Data Platform is connections, not only connecting data to the analytics or connecting data to certain employees, but also connecting users to different types of data and connecting users to each other. Also being able to discover analytics and new data sets and accelerate how you can bring something into action through the insight. And another big idea is the paradigm shift with data not necessarily needing to be siloed. I mean, some definitely does need to be siloed, but we want customers to be able to collaborate with each other and communicate very well. And this obviously drives intelligence faster going to market with these insights. So some of the things that I'll be highlighting today are Bluemix, IBM's cloud platform, Watson Analytics, a business intelligence tool, Data Hub and Data Connect, Data Science Experience, and then more storage, analytics, governance, and security along the way. So I'll be going back to this slide just so that we do touch on each of these personas. But what I'll jump into is a real-world application of Watson Data Platform. So here I have a data set that I downloaded from Kaggle. It is a housing price data set. So the main value is this sale price. This is how much a house sold for. And then everything else is just attributes or features for that price. So we can look at something like the square footage, the area of the garage, what year the house was built, what year it sold, and all of these can theoretically contribute to the sale price. So right now you could imagine a company like Zillow, who is an online retailer for houses. Users can log in, post their house, and someone can look at it and buy. And then they would collect data like this from the users who are posting their houses. So right now that's just kind of a bare bones potential application and data that's being collected. So if we look at our personas, let's start with a business analyst who maybe read an article online and knows that they can be doing more with data science or more with the data that they're collecting, and they want to validate that and kind of get into the data and see if there's anything that they can discover. So with most data that's being collected, it's not open to everyone in a company. and that's where a data engineer would come into play. So in this case, a business analyst would request the data, and we have this tool called Data Connect, which allows for the movement of data between, from one location to another. And in this case, we're going to be moving that data, which I have in Postgres on Compose, to Watson Analytics, which is the business analyst tool. So, and I hope I'm mentioning everything along the way. This data is in Postgres. I downloaded it from Kaggle, but I uploaded it into a Postgres database on Compose. So if we go into Data Connect, I can look at the connections that I have. I do have Watson Analytics, and I do have Postgres, so I'll be able to move that data. I can create a connection to a ton of other places, like Cloud, but also non-IBM products like Amazon S3, because companies have data everywhere using a whole bunch of different technologies. But in this case, I do want to copy over some data. So I've got the data in Postgres, this public schema. In this case, we're using this housing price data set. I can also select the columns in a data set if, let's say, you're collecting social security number, but you don't want others to have access to that. You can remove it when you move it over. In this case, I would copy it to Watson Analytics. I can also do other things like changing a column or blanking out certain values in the Data Connect interface. But in this case, I would just run this. I've already done this, and I have it in Watson Analytics. So coming back here where the data engineer moves the data to the business analyst, and I can go over to Watson Analytics now. So I have that data set here, this housing prices data set. I can also add other data sets if I have a connection or if I want to upload a file. But in this case, we already have the data here. And when you think of a business analyst, it's someone who doesn't necessarily have a technical background, but from just uploading this file or just making a connection to this file, it gives me a bunch of recommendations and descriptive analytics without having to do anything. So if right away it says what drives pool area, and obviously if a more expensive house probably has a pool, and if a pool is larger, there's probably other things that come into play, like they would probably have a larger square foot or something like that. And that's Watson Analytics can find all these things out without even asking it. But in this case, this business analyst wants to start making recommendations to their customers for what to price their house at when they want to put it on the market. So again, picture a Zillow user coming in and wanting to post their house. They're maybe not sure at what price they should put it at. So if they could make a recommendation for a good price, then obviously, if the price is too high, it would take too long to sell or not sell at all. If it's too low, then their user didn't get as much money as they could have. So we can just ask Watson Analytics with plain English what predicts sale price. And then right away it gives me a decision tree model for sales price, and it gives me a bunch of contributing factors. So let's look at those. And right off the bat, it says, the biggest factors are greater living area, so square footage, in the neighborhood it's in. It looks like basement quality is a big indicator for sales price. So it looks like this data set's pretty good, and it looks like they'll be able to do something with it. And if they're interested, they can also look at, as I mentioned before, a decision tree for the biggest factors and how they can contribute. So they're collecting overall quality of the house, which looks like it is the biggest factor. And then a bunch of other things that kind of put a house into a bucket of how much it would sell for. So as a business analyst, this looks really good. It looks like this data set is useful. And now they can qualify that to make a business decision. And in this case, the word gets to the data scientist who also needs access to this data to try to productionalize this, to try to maybe make a model that could make these recommendations when a user visits the site. So again, going back, we had the data stored in Postgres, which the data engineer gave access to the business analyst, and now they're going to give access to the data scientist, which is the exact same thing that we saw a second ago. Instead of moving it to Watson Analytics, we can move it to Bluemix Object Storage, which is where I have a project set up that a data scientist can access that data and now make a model or find correlations and that kind of thing, which we'll see in just a second. So in each step of the way, each one of these tools is really vast. I hope I'm not going too fast through it. And if you have any questions, we can dive into it. But moving into the data science department, this is data science experience, which is very community driven. There's a bunch of articles in terms of learning data science. There's data sets that you can access, notebooks for seeing what other people have done and maybe applying it to something that you want to do, and also tutorials for learning. Data science experience is project driven. So everything that you work on is inside of a project, and each project can have many collaborators, and it also has data that can be accessed in that project. So here's a bunch of projects that I'm in. Some of them I have a bunch of collaborators. Some of them it's just me. In this case, I'm the data scientist that will be doing these analytics. This housing price data has already been moved over, so it is in this project. And here I already have a notebook set up, but I could add another notebook. I could add collaborators. But from here we can just dive right into the project and see what I've looked at. For this notebook, we can also add comments and share it. I'll go into edit mode so we can step through this code. And this is, I'm a little biased because I have a software engineering and data analyst background, so I'm probably more excited about this, and I think this is one of the bigger steps, but as I mentioned earlier, it kind of became clear to me that not all companies have that thriving data science department that you might expect. So all the steps are big important steps to get to the end goal. So here I see I have Spark in the background. So later I'll be running some Spark code. And I just want to highlight that if you have the freedom to access the data in any way. In this case, I can access the data directly from Postgres if I have the credentials to do that. But I also am accessing it here through the data that was moved over through Data Connect. Just depending on however a company wants to govern their data, they have the freedom to do that. And then from here until the end for this notebook is the steps that a data scientist would use to create a model. So here they're just taking a really quick look at the data. They're going to look at the schema, all of the features that relate to, again, the sale price. I hope I have some visualizations here that I'll try to run. And a data scientist also just want to validate the data that it makes sense. So in this case, we're looking at the sale price compared to the square foot, the greater living area. And yeah, there is a clear correlation as the square footage goes up, the sale price goes up. So this data set does look does look useful. And then from here on out, I'll be doing some machine learning on Spark. I've created a user-defined function. A lot of these features are, for example, the square footage of a pool. Some houses don't have a pool at all, so it was NA. So a lot of these I'm kind of just, for the sake of creating the model, I'm either making it a yes, no, they had a pool, or they had a access to an alley or something like that, rather than creating more features. So I'm doing that really quick here, and I'm creating an initial model. I'm going to use a random forest regressor, and this is just right out the box. It looks like, whoops. Right out of the box, I train a model, and it has a root mean squared error of 35,000, which isn't great. We could try to improve that. So I do a grid search with 3 folds, a bunch of different hyperparameters, and we improve it to 33,000. So not too big of an improvement, but an improvement nonetheless. And in a real-world situation, there would probably be, this step would probably be have quite a few more iterations. But again, in terms of getting the model and improving it, we made it to this step. So let's go back over to where we are here. The data scientists got access to the data. They were able to visualize it, do some correlations, do some machine learning. And from here is the last big step for that, for the company, is putting it into production with an application developer. And that's where IBM's Bluemix Catalog comes in. In terms of Bluemix, it has everything that you'd expect from a cloud environment. You have compute, bare metal servers, you have storage. You can host applications through boilerplates or Cloud Foundry apps, and containers as well. Like I said, I mostly focus on data and analytics. So if you needed a Hadoop cluster, if you want to use Apache Spark, in this demo I'm using Postgres on Compose, and that's here as well. And then the one thing on top of that is all of the Watson APIs, things like text-to-speech, conversation, tone analyzer, all on Bluemix to be able to run an application and store it on the cloud. So just going back here, what we walked through is an application that's on the cloud, writing data to Postgres, a data engineer using Data Connect to give access to certain pieces of that data to a business analyst and to a data scientist, who move an idea that a business analyst had, into production to help out an application. So, like I said, there's a quick overview of Watson Data Platform, and hopefully there's a couple questions of deeper dives that we can go into the pieces along the way.
There are no questions right now, Ross.
Yeah, if there's not questions, the one thing that I would like to spend a little more time on is data science experience, which again, take it from the beginning of the end, to get from the beginning to the end of the story. I just go into data science experience and show that it, what an outcome could be, but there's quite a bit more to it. Again, looking at the community page, I can just pull in a notebook and run the code that someone else has written, and this is great for learning and education, but also for reusing code that's already been written in a similar use case that you have. And obviously access to data sets and articles really help a data scientist grow, as well as the tutorials. in data science experience, you can use RStudio. So if you want to write R code, you can. I used Python in my project, but you can run Scala as well. The big driving factor being scaling anything that you do on data science experience is easy because you're using Spark. So if you have a data set that's 1 gigabyte, it's the same code if you're using Spark as if it's 1 terabyte. So I think that's something that's really powerful about scaling with data science experience. And another big thing that we have with data science experience is Data Hub, which, as I mentioned before, everything's really project driven. So say you have a certain team on a project in data science experience, and you want to give access to a certain data set to that project, you can do that through a catalog. So if I have that housing price data set in this catalog, but also something maybe a little more sensitive that I want only the people in that project to see, I can add that to the catalog and then add the catalog to the project. And it's a great way to organize not only teams to work on certain projects, but also data for who has access to it. I think it's a really powerful tool to use in terms of a data science team's workflow. So I don't have too much else to touch on. Anna, if there's no questions.
Are there any questions? No, I don't have any questions right now, but are there any questions that anyone would like to post via the chat room? Okay, so I guess this concludes the presentation. Yes, I just got a question. The webinar is being recorded. You will receive an email with the link to the recording within the next 24 hours. And with that, thank you so much for joining us today. And thank you, Ross.
Oh, yeah, no problem. Thanks for having me, Anna.